right, hello you guys. Today we're taking on geometric distributions using the graphing calculator. It's our big day of shortcuts. Okay, and I have one little typo. Cross this guy out and write CDF, and then I'll get started. All right, so first up, we're looking at the two shortcut functions in our calculator. So GeoMet PDF is an abbreviation that's used for a geometric probability density function. So here we use for calculations where we're looking for a success on the xth try. So we use for calculations where we're achieving our success on the xth try. Okay, and then GeoMet CDF, so the abbreviation of CDF is used for a geometric cumulative probability density function. So that word cumulative is coming back, and again, it tells us running total. So we use for calculations that are at or before, we get that success at or before the xth try. Okay, so again, how do we get there in the calculator? We saw this with Binom PDF and Binom CDF as well. So we know that we're using second vars, which takes us to our distributions. And we're looking for GeoMet PDF and GeoMet CDF. Okay, so if we're using GeoMet PDF, we put in that p-value first, the probability of success. And then x is, well, the number of tries until we get to our success. So if I'm getting success on my third try, I would put in a 3 for the x value. So this is that number of tries until we achieve our success. And if we're using GeoMet CDF, the p is still the probability of success. And the x would be, well, number of tries, but at or below this number of tries. This one is the cumulative function. Okay, excellent. So again, today is our day of fancy shortcuts. So here, a baseball player gets a hit with 30% of pitches while at batting practice. Find the probability that the baseball player goes to batting practice and gets a hit on the first pitch. Okay, so here, I know my answer should be just 0.3, but let me show you how you do it on the calculator. So we know that the x value is 1, right? We are successful on that very first try. So we should be typing in GeoMet PDF, and then 0.3 is our probability of success, right? Getting a hit 30% of the time. And we want to be successful on that first try. So here we go. I'm looking at second vars. I'm going all the way down to my geometric, see, here my GeoMet PDF right there. And then I'm saying 0.3, 1. So here is my probability of success, right? 30% of the time we get a hit, and we want to get a hit on that very first try. So I can hit enter, and it gives me that 0.3, which I already expected. Okay, on the fourth pitch, so that means that we have 3 failures. We got 3 no hits, right, until we finally get that hit on that fourth try. So here again, I'm using GeoMet PDF 0.3, 4. Okay, and something that I can do on these calculators also is I can retrieve my previous keystroke. So if I hit second enter, so enter is right down here. So if I hit second enter, it pops it back up for me, and I can just go over and edit and make that a 4 instead. So that gets me 0.1029. Still exact. Okay, now I'm saying before the 6th pitch. So that means if it's before the 6th pitch, we could have been successful on the 1st, 2nd, 3rd, 4th, or 5th try. So now I can use that cumulative function. So geomet, and then CDF, 0.3, comma 5. So here, that 5 is 5 or less. All right, so let me show you both. So here I'm going second verse. I'm going all the way down to geomet, CDF, and I'm saying 0.3, comma 5. So that 5 says, well, you're successful on the 5th pitch or something previous. So I get 0.8319, about. Okay, after the 5th pitch, so this was before the 6th, after the 5th, well, let me define that. That means it could be 6, 7, 8, etc. So I need to go through the complement. So I'm going to do 1 minus the probability of being successful on the 1st try, 2nd try, 3rd, 4th, or 5th. And how lovely, right? That's what I just solved for. So I can build off that previous answer. Just to show you the keystrokes, it would be like 1 minus geomet CDF 0.3, comma 5. Okay, and again, that's what I really solved for up here. So I'm just doing 1 minus 0.8319, and I get 0.1681. Okay, next up, in less than 5 pitches, so less than 5, right? That could be successful 1st try, 2nd try, 3rd try, or 4th try. So I can go straight to geomet CDF 0.3, and then 4 or less. So here, since that was the last thing in my calculator, I can again just build off of that and change this to a 4 instead. So I get 0.7599. Okay, and then here for problem F, in more than 6 pitches, so more than 6, right, it could be 7, 8, 9. So here again, I got to go through the complement. So 1 minus the probability that we were successful 1st, 2nd, 3rd, 4th, 5th, or 6th. So 1 minus geomet CDF 0.3, comma 6, 6 or less. So here, if I type that in, let me just cover up for a second. Here I'm doing 1 minus second verse, going down to geomet CDF right there, and I'm saying 0.3, comma 6 or less, and I get 0.1176. Okay, next up, well, if we have our baseball player just keeps getting pitches until he gets to a hit, how long do you expect it to take with what standard deviation? So here again, it's saying, well, what's the mean? What is the standard deviation? And then, give me a little context. So here we're looking at a geometric outcome. So I'm looking at 1 over p. So I'm looking at 1 over 0.3. So my mean would be 3.3333, about. Right, so on average, we expect about 3 1/3 pitches until he finally gets a hit. Okay, with what standard deviation? So here, big square root, q over p squared. And again, right, I'll give you these formulas. I don't need you to memorize that. So here I have 0.7 and then 0.3 squared. So when I type that in, I should get about 2.7889. Okay, so then adding the context, we'd say, well, we expect an average of 3.3333 pitches until he gets a hit with a standard deviation of 2.7889 pitches. All right, that's my geometric distributions using the graphing calculator lecture. I hope it makes sense. Please start sending in questions if any arise. Have a good day.